Welcome to fourth lecture of chapter 4, and today is the last lecture. Okay, today we'll discuss about free fall, weightlessness, right, and weightlessness, and the name the places where weightlessness is held, and where there is more weight, equator or poles. And we have done these questions also in the previous lecture. And things you should note it down. The value of g at equator, g at equator, and mentioning this way, this value is 9.78, and as you know the unit 9.78. And the g at pole, we generally take, sometimes it is also asked, g at pole is 9.83. Now why there is a difference is due to its radius. Now let's, and also I will solve few objective questions and few left questions in this exercise. Okay, let's go up. Okay, therefore where there is more weight, poles or equator. I have told earlier we have learned this formula. G is inversely proportional to 1 by r square. And how we got this one is, I want to write an equation. Okay, see here, g equals to, we know the formula, gm by r square, and we told g and n are the constant. That's why g is inversely proportional to r square. We told gm by r square, and we took out the constant. What are the constant? If g is constant and mass of the earth is also constant, let's change the unit. Yeah, see, this is a constant value, so we remove that constant and we got g is inversely proportional to r square. And earth is not perfectly square. The radius of equator, this is, we call this as equator, and this is as pole, this is equator, and the radius of equator is more. If radius is more, acceleration due to gravity will be less. And also w equals to mg, or we can write w is directly proportional to g. These are the all these formula we learned in previous classes. We removed the constant, so we got this two relation, one, this and this. With the help of these two relation, we are going to write the short questions of this, where there is more g, pole or equator. Okay, now I think you understood. The radius of the equator is more than that of pole, so acceleration due to gravity is less than pole. Also w is directly proportional to g, so weight is more at pole than equator. You can write the answer in that way. Let's go down. And also another questions they will ask, where there is more weight, top of Everest or the bottom of the Everest? Top of Everest, top or bottom? Okay, how do we solve such questions? We realize the question in this way. Let me go to this. Okay, here, this is the earth, and let us make this as Everest. So this top, this is the top Everest. Okay, and okay, this is the top of Everest, and this is the bottom of Everest. This is the bottom. Okay, this is the top. This is the top of Everest. Top, bottom. Well, what we have learned, now we will finalize where there is more g. Let us think where there is more g, and answer means always g is, we know g is inversely proportional to r square. Radius, don't say one radius, distance from the center of planet to the center of object. So generally this is the center of planet, and the top of Everest means this one, and bottom of Everest is this one. Now let's draw a line. Just I am making this figure to realize how we can answer. Don't write everything while answering that question. Okay, now obviously this distance is more, this distance is more, so what we can say, okay, what we can say, the distance from the center of the planet, the distance, this is called the distance from the center of planet to the top of Everest is more than the distance from the center of planet to the bottom of the Everest. Again I am saying the distance from the, this is the center of a planet, this is a planet, so the distance from the center planet to the top of Everest is more than the distance from the center planet to the bottom of the Everest. So if distance is more, then the gravity will be more at the top, sorry, bottom, because if distance is more, gravity should be less, so G is less at top. If distance increases, gravity will be less. Similarly, if gravity will be less, then weight will be also less at the top of the list. Now we'll answer in that in the same way. I think you understood. If I have to say the answer again, the distance from the center of planet to the top of the Everest is more than the distance from the center of planet to the bottom of the Everest. Also, we know G is inversely proportional to the square of distance. So, at the top of the Everest, G will be less. Hence, W is also directly proportional to G. So, weight is more at bottom of the Everest. Let's go down in the similar way, write the answer in the similar way. Just realize that formula, radius, gravity and weight. Now next we'll learn about free fall and weightlessness. Now free fall is defined as falling object towards the center, just like a thing like acceleration due to gravity and gravity. We have made a figure, we have made one figure. Let me go up, let me make a bit of. While learning about free fall gravity, we have made a figure and we think this object is coming down. Yes, the same, exactly the same case is also a free fall. There is no resistive force. If a body falls downward, nothing is pushing it up, and such case is called free fall. Okay, no resistive force is there, nothing is pushing it up, so such scenario is called a free fall. So right here, free fall means falling of object towards the center of earth under the influence of gravity without air resistance. Air is also not pulling it up. Okay, I think you understood. The falling of this object towards the center of the planet without air resistance, or there is no resistive force that that takes this object towards upward direction, no force, upward direction, no force, then that is called a free fall. And what is weightlessness? Weightlessness means weight equals to zero. How it is possible? Now let me go here. I don't have space down now. Okay, I'll write down. Weightlessness means there is a mass, W equals to mg. You have learned this formula, W equals to mg. Though there is a mass, but you don't see the weight. Weight is zero. You don't feel the weight. It means that if there is a mass, then mass is not zero, G is zero. That's why you feel the weight. So G is zero, W equals to zero. So this is called the weightlessness. You can say that weightlessness is the condition of a body having a mass but no weight. No weight means weight equals to zero, but there is a mass. Such case is called weightlessness. Weightlessness, where we observe the weightlessness, it is also asked sometimes in 2 marks question or 1 marks. Weightlessness is observed in space. In space there is gravity zero. We take G equals to zero in space, so weight is zero. In center of planet also we take G as zero, so weightlessness is also zero. And during free fall, now again it might be confusing. I'll discuss later on. Okay, on the earth's surface we will not find free fall. Why? Because there is air resistance on the earth's surface, not other planet. Other planet will feel weight free fall, during free fall there is weightlessness, but due to air resistance, but falling of an object in the moon or other planet is free fall. Okay, I think you understood. In earth there is an atmosphere, so we don't find free fall because the air is pushing the object upward, so in that case we don't say that is a free fall. Okay, let me go down. But the falling of an object in absence of air resistance, yeah, if there is air resistance, if there is no air resistance, I have made in the last figure, okay, that like box type of this box, the air is removed, which object will fall faster. I have done the next previous class. So both heavy and light object will fall at the same time. Yes, if there is no air resistance, but in earth there is air resistance, so heavy will fall faster and the light will fall later on. Okay. In the absence of air resistance, both heavy and will fall at the same time. And if you remove the air, then we call that is a vacuum, and there is no air resistance. Okay, during free fall, why the weightlessness is zero? I have to discuss this also. This is also quite important if you think it. During free fall, what is the if object 10 kg mass? Let us consider a 10 kg mass over here, and it is falling towards the earth, and this is our 10 kg mass. Now, what is its weight? Weight equals to 100 meter. Yes, mg mg equals to 100 meter. Now, if there is no air resistance, then what is its weight? We say the 100. But here is quite a bit confusing case. During free fall, and if this body is falling freely and no air resistance, what should be its weight? Its weight should be 0. Now, how do we think and we'll write the answer is okay. I am drawing this. I cannot get eraser. Okay. Now, generally, how do you write weightlessness during free fall is 0 is weightlessness equals to, now think, if the body is falling downward, if this body is falling downward, then what is the resistive force? Now you should find the resistive force. What is the force that brings it up? What is this force value? It's 0. So weightlessness is 0 during free fall. This is the case. We are not taking the same object weight and we are saying weightlessness, but we are saying that if an object is falling, if this object is falling towards the earth, okay, it will fall towards the earth. If it is 5 kg, it will be 50 newton weight over there. Now, what is the resistive force? What is the amount of force that this any other object will give towards it? This is a reaction. That will be 0 because there is no air, nothing is pushing it upward. So during free fall, we say there is a weightlessness. During free fall, we say that there is a weightlessness. I think you understood, and this also fact I think you understood. I have done half of this in the previous class. Okay, let's discuss some short questions. These are the things. So, and many times it is asked in 1 marks, what is free fall, what is weightlessness. Now I think it is understood that free fall means there is no resistive force, no force is acting against the falling object. Yes, object will fall towards the center. Now the definition is clear. What you can say, falling of an object towards the center of earth under the influence of gravity. Yes, it will fall under the influence of gravity, but there is no air resistance. Okay, let's go down and we'll solve this question. A man can lift 118 Newton on the earth's surface. How much mass he can lift on the Jupiter? Now see, this is the case of earth. It is done in earth. It is done in earth. And how much mass he can lift on Jupiter? It is the action Jupiter. So if a man has 100 Newton force, if he can apply on earth, he can apply the same amount of force on the surface of Jupiter too. So what you can write? Force on earth. Force on earth equals to force on Jupiter. And generally force we know, force equals to mg. M of earth, I'm writing E earth, and G of earth equals to, you can write here M on Jupiter. We are doing this case on Jupiter, and G at Jupiter. Now question is asking, sorry, I am writing G over here, Jupiter. Just dimension is that one. Now mass of earth we don't know. Mg overall value we know. This should be 1800. Yes, this should be 1800. And mass of Jupiter we don't know. We have to find this mass of Jupiter. And what is the value of G at Jupiter? I have told in previous class it should be 25. On the moon it should be 1.67, so 25. Now calculate value of M. Okay, 104 18 4 72 should be answer. Okay, after calculating you will get 72 as an answer. I think you understood. Force on earth and force on Jupiter is same because the same person is carrying on the both surface and you will have the same force. And also the mass of earth and acceleration due to gravity on earth, force equals to mg. So I'm taking the both on the surface of the earth and both on the surface of the moon, mg. So overall a person can 1800 newton is given, so overall this value is 1800. And mass of Jupiter into Jupiter value g is this value is 25, you should memorize. After calculation just divide 1800 by 25, you will get this 72 as an answer. Let's go down. If a person can lift 600 newton on moon surface, it acts on the moon surface. Now how much kg it can lift on the moon surface? Overall the both are acting on the moon surface, so there is no problem. In that case f equals to mg, and I am solving all this case on the surface of the moon. And force is given as 1600 newton and mass as it is, and g value on moon is, I am just taking 1.6 to get the easier calculation. And just you divide m equals to 1600 by 1.6, it means you will get 1000 answer. Just divide this value, you will get 1000 answer. Let's go down one. Okay, let's go on this question. If a mass on, if a man can carry 1000 on the moon surface, that is acts on the moon surface, and how much kg can carry on the earth, is acting mass on the earth. So overall, if a person can carry 100 kg on moon surface, what amount of force he can experience on moon, that is mg. So m into g, that is 1000 into g value on the moon is 1.6, so you will get 1600. Just I have taken force on earth equals to force on moon. Force on earth is equals to mass into 10. Why? Acceleration due to gravity is 10 on the surface of the earth, so equals to 1000 into 1.6. Let's cancel the value. You will get mass on the earth equals to 1600 and 160 kg. This is also quite important question. I think you understood. Just I cancel this term, and so 1.6 into 100 is 160 kg. And these are also quite important questions you will get in exam. This much for today. Now I'm going to solve some left problem. I haven't solved a few problems from the book, so I want to solve those problems. I will be very quick. I'll not solve almost questions, but I'll be very quick. The force of sun and earth is called, you know, the this should be, let me, okay, this should be gravitation force, and the which causes tide gravitation force. The force of attraction due to sun and earth is called gravitation force. Now I want to solve these questions. If both mass are double and distance are, how many times the gravitation force will increase or decrease? You might get this question as in 4 marks to solve long question type. And how do you solve this? The both mass are double and the distance are fixed. Okay, now just think one mass, another mass, and the none of the value is given, so think this distance is d. Okay, just I will make you understand the question, and I'll solve. I'll pause the video, I'll solve and show to you. This is empty. This is the original scenario. The question is saying, now what will be the amount of force? You know the amount of force. I am saying this is F. Okay, now force will be G m1 m1 m2 by d square. This is the force. Now what the question has changed is, if the mass are double, and now read the question again carefully. If the both masses are double, and this, if this is m1 and if this is m1, now I'm changing the ink and I'm saying that again I'm making the same mass, the mass is double, then this should be 2m1. Okay, you could solve it easily if you know the compound interest, how you are solving compound amount problem. If 2 times 2 year and 3 years are given, you will also solve here also in the same way. Okay, and another mass also should be double, 2m2, and distance is kept fixed, and distance is kept fixed means this distance is also d, because we have the present original scenario, there should be d. Now what will be the force over here? I'm writing force as f dash or f1, and the same thing. Now it should be g, and what is the first mass? g dot 2m1 next 2m2 by d square, because distance is not same. Let me go down. Now just arrange this, how much value you are getting over here. G 2 to the 4, okay, 4, you are getting 4 g m1 m2 by d square. Now what is the value of g m1 m2 by d square? It is 4f. It is the original value, so it should be written as 4f. So we think that if we increase the both mass twice, then the force due to gravitation will be increased by 4 times. Let me say it again because you should understand such problem. Okay, sorry, okay, we are running, we should make our class longer. Let's go off. And always in such case, if the distance are fixed, first mass is twice, second mass is twice, you will have the same scenario to solve, and you will solve in the general way. And this is I am solving general way. Just make two masses, no need to make figure. If you understand, just write f g m1 m2 by d square. I am doing it so that you will understand. And think the first mass, second mass, and m1 m2 and d square. I am taking the original case, and f equals to g m1 m2 by d square. And I'm reading the question. What the question say? Both mass are double and distance is fixed. So I have mass. See, I have double the mass. I have double the mass over here too. So I have calculated again force, and I'm saying this force, new force is there, and so I'm writing here f1. So you got the value 2 to the 4, overall the same value. So 4 times f. And what you can conclude, the gravitation will be increased by 4 times. In the same case, read the question number 5. If the both mass are double and the distance between them is half, then how much time the gravitational force will increase? Now the distance is half and both mass are double, and I should write over here. Okay, this original scenario will be same. This will be same. Okay, this will be same. You can do just dividing the equation 1 and 2 also. And the second case it will be different, and the distance is also half. 2m1, both mass are doubled. I have doubled the mass and distance is kept half. Okay, I am solving this one, question number 5. And the distance is made half, means what I can do, I should write here d by 2. Now also I should put here d by 2 whole square. Now I think I should rub it all. What I can do, I should write over here d by 2, distance is half, means I am mentioning the d by 2 over here, d by 2, okay, whole square. Now how much value you are getting? You are getting, okay, let me rub this also. Now I should calculate rigorously the mathematics over here. It will be f1 as it is, okay. And what you can write, this 2 to the 4 will come, and d by 2 whole square, this is something like 1 by this main equals to 1 by 2 square is 4, so it will also come up. So this 2 will also come up. You can calculate, use your mathematics, 4 into 4, and what you will get, g m1 m2 by d square, and we are getting 16 times f. It means force multiplied by 16 times in that case. You can also write equation 1, this is equation 2, dividing, and you will get that answer. Okay, I'm pausing this video. I am doing next another also. This is the last question I am doing for today. If both the mass are double and the distance between them are also double, by what factor gravitational force will increase or decrease? I am muting the video. I am pausing it, and I'll solve it and I'll show you. Okay, well, previously answer should be this one, 5 number question. Now question number 16 I have read before for you. Mass are also double, distance also double. So I am taking again the original scenario will be the same. Let me change it. Okay, this scenario, okay, I want to use this one. Okay, this scenario will be the same, original case. Now the question says mass is also double, I have written 2m1, and distance is also double, I have written 2m2. This is m2, and the distance is also double, so I have taken distance as 2d. D is here, that's why I have taken the 2d. And I have tried to find the gravitational force G, and this mass into this mass by this distance whole square, and I got here also 4, here also 4. 2 square is 4, so it will cancel, and the force is not changing in such case. So I should take the answer no change in value in the force. In the similar way, let me I have where the value will be. Okay, you can solve in the similar way till here. And here the acceleration due to gravity is minimum at acceleration due to gravity is minimum at, we know that it is at center of the pole, and you have learned among this pole and equator, you have told the G is more at pole than equator. You have learned it means at the center G is 0, so G is minimum at 0. Next question, where the weight of the stone is minimum. So if G is 0 at the center, weight is also 0. So this is center of the object or, and in what factor the rotation of earth doesn't affect the acceleration due to gravity. So it doesn't affect means the value is maximum, G should be maximum, always think in that way. Any rotation of doesn't affect the value of G means where there is maximum value, so it will not affect it over there. So at the pole you should write the answer at the top pole. If yes, though the video will be larger, longer. Okay, I want to solve till this question number 12, and this is quite good questions to think. If an apple is moving on the surface of the earth, so this is earth and this is the small apple, and this also falls, feels the force of gravity towards the earth. This is the earth and this is apple. Now if a apple is on the surface of the earth, then what is the ratio of force of apple to the earth with force of earth to the apple? It means that this apple also gives force to the earth, and earth also gives force to the apple, but the apple is moving towards the basically apple will fall towards the earth. Why not apple will pull the earth? This might be the questions. So I think it seems interesting. Again I am saying that here is the earth, here is the apple. The apple will fall towards the earth, but also earth is also, apple is also applying the same amount of force towards the earth, but why not earth is moving towards the earth? So for that case, what do you think is force by apple on earth? I'm writing FAE. Okay, FA. It means that force given by apple on the earth equals to force given by earth to the apple, and earth will experience the force equals to m mass of apple and acceleration of apple. But generally this apple will experience mass of earth and acceleration of earth. Now think here. Now I have told you this apple will move towards the earth, so acceleration of apple is, we can know the value, or this is quite this is a bigger value, we can calculate this value. Now we are thinking about what about acceleration of earth. So why earth is not accelerating towards the apple? It means that AE, what is the value of AE? Use that mathematical expression from above. What's mathematical? Okay, AE equals to, you can write m of apple by mass of earth, into acceleration of apple. Okay, till here I think you understood. Just we have manipulate small mathematics. F equals to ma, mass of earth into acceleration of earth, mass of apple into acceleration of apple. Acceleration of apple we can calculate value. Let us think it is 10 meter per second square, something value like that. So what do you think? Mass of apple is just 2 kg. It means it is a bigger apple. We can't find a mass of apple 2 kg also. We can't keep here 1 kg also. Yes, 1 kg also we can't find the apple of 1 kg. But think about mass of earth. Mass of earth is 6.6 into 10 to the power 24 kg. It means something value like this, 1 divided by 1 divided by this value. So if you calculate this value, it will come 0.00024 times 0 into 1 or something like that. So we don't feel acceleration, that acceleration on the apple. So from here it is clear that force given by apple to the earth and force given by earth to the apple will be the same. Its ratio is 1 is to 1. And from here we have concluded why apple is not moving towards the earth surface, and why earth is not moving towards the apple. I have solved almost questions from this chapter, and from next class we will learn the pressure. Thank you for listening and joining my class. Thank you.